All right, pH. pH is a scale that we use so that you know how acidic or how basic something is. So with pH, you have 4 different calculations or 4 different formulas that you need to know. And I'm going to go ahead and write those formulas down, and we'll be referring back to them as we go. So write down pH pH. Now pH is written with a small p and a capital H. The capital H stands for hydrogen. So whenever you write pH, that stands for hydrogen, equals the negative log of the H plus ion. Now, in your book, H3O plus equals the H plus ion. So you will see professors use those interchangeably. Whenever you have a hydrogen ion, it's also called a proton because there's no electron on this. There's one proton and no electron. Whenever you add one of those hydrogens to water, you get the H3O positive ion. So these are interchangeable. And I usually write H plus because it's usually plus. Your book has H3O positive. The next one we have is POH is equal to the negative log of the OH negative concentration. Another thing on your handout, it tells you that these brackets mean molarity. So if you're given a molarity, that would be a concentration, and those brackets mean concentration. All right, you also have a formula that says pH plus POH is equal to 14. And I'll explain a little bit more about these in a minute. The last one is that the H ion concentration times, there's nothing in between, that means times, OH concentration equals 10 to the minus 14. When you read your problem, it's important to know, am I working with an acid, an H with something, or am I working with a base, something with an OH? An OH, when it's in water, will a strong base will ionize into something plus OH. 90% of the time, the molarity of this is the same as the molarity of the OH. Okay? For example, if I put Na here, okay, then I would get Na plus here. This is called a net-on equation. We learned about it earlier. And if the molarity of this is 0.002, the molarity of this is also 0.002, and the molarity of this is 0.002. Because, if I want to know the molarity of the OH ion, it equals this molarity, 0.002 moles per liter. Now, how am I going to change from NaOH to OH? Mole-to-mole ratio. It's the mole-to-mole ratio. 1 to 1. And that's what you're seeing on the sample problems that work with it. You see that they're doing the mole-to-mole ratio here of 1 mole NaOH to 1 mole OH minus. Okay? Now, let's pretend for a moment that this was mg. Get my eraser here. I'm going to erase this a bit. Erase that a bit. And now we're going to put mg here. This has to be in parentheses too. And this would be mg plus 2. And I would have 2 of those. Now what's the mole-to-mole ratio now? 1 to 2. So this molarity for OH would be double. 10% of the time you see a problem that has that. So when you look at your acid or your base, if there's one OH, then the molarity of that base is the same as the molarity of the OH. If you have more OHs, then you have to account for that in your formula. Because your formula asks for the OH concentration, not the MgOH concentration. Okay? Same thing with the acid. If this were HCl, that's going to yield H plus, or H3O positive, whichever way you want to write it, plus Cl minus. I'm interested in that concentration. So you see there's a 1-to-1 ratio there. See, if you add an H ion to a water molecule, you get H3O positive. And they are interchangeable. They're used interchangeably. Your college professors may use H3O positive every single time, or H plus every single time. Or mix and match. They may use one time, one next. It's whatever the answers, they are the same. Whenever you put H in water, it's attracted to the water molecule and forms H3O positive in solution. All right, so those are your formulas that you need to know. Okay, let's clear this off. All right, now this is something I wanted for you to see, is that on this we have the pH and the H positive, and I'm going to add to it the H color will show up there good. Okay. Thinking the purple maybe will show up. All right, I'm going to add POH. I don't want to put on this side.
This is the thing that MVP had a series of everything. It like switch for the color. That was
I don't know what he was carrying around. So POH and the OH minus concentration over here. If the pH is 14, what do you think the POH is going to be? We have a formula that says pH plus POH equals 14. So if the pH is 14, it's going to be 0, because 0 plus 14 gives me 14, right? So the pH is 14, so the POH is 0. I also have a formula that says that the H ion concentration times the OH ion concentration equals, and your book says 1 times 10 to the minus 14. I just say 10 to the minus 14. When I multiply two exponents, what do? I say x to the third times x to the fifth. You add exponents. We do the same thing this time. You add exponents. So, if this is 10 to the minus 14, what does this need to be? 10 to the 0. Okay? With me? Where's it gone? Everybody else has got it. So the OH concentration is 10 to the 0. Any number raised to 0 power is equal to 1. Okay? So we have a pH of minus 14, which is very basic, and we only use pH for fairly dilute solution. We don't use it for those concentrated acids back there, because then the pH is negative something. So these are for fairly dilute acids, not strong acids. All right, so if I have probably the most basic I can get, I would expect to have no acid content. Okay, so I have all of the available ions are OH ions, and none of them are going to be, or basically none of them. 10 to the minus 14 is an extremely little bitty number, right? Extremely, 10 to the, we got point and 13 zeros and a 1 there. So it's a really little bitty number. So we have a whole lot of OHs and not many H's. With me? And as one goes up, the other one goes down. So I'm not going to do every single one. I'm going to drop down here to the 7. If the pH is 7, what is the POH? If the pH is 7, what's the POH? 7, because 7 plus 7 equals 14. And if the H concentration is 10 to the minus 7, what is the OH concentration? 10 to the minus 7, because minus 7 plus minus 7 is minus 14. When you multiply these two numbers right here, I should get 10 to the negative 14. With me? Okay. Now I'm going to go down to, let's say, a pH of 1. If the pH is 1, what's the POH? 13, because the two of them add up to be 14. And if the H concentration is negative 1, 10 to the negative 1, what's the OH concentration? 10 to the minus 13. So this number is getting smaller as this number is getting bigger. Remember the negative exponent, it's a little reverse in how you think about it. That's a little bitty number, and 10 to the first is a fairly large number. At the same time, as the pH gets smaller, the POH gets bigger. Okay? So at any point along here, if the pH is 10, what's the POH? 4. So we got 0, 1, 2, 3, 4, 5, 6, 7, so forth. You see that? And as this pH, the H ion gets bigger, then the OH gets smaller. So so this is going to be 10 to the first, 10 to the second, 10 to the third, minus, all those are minuses, minus 3, 10 to the minus 4. But when I take those two numbers times each other, I get 10 to the minus 14 all the way through. Okay? So they kind of depend on each other. And there's always some of both things in there. Water is our neutral. And water has 10 to the negative 7 of each of the ions in it. It's not without those ions, they're just equal to each other in that point. Okay. All right, I also thought that this, I think this next graphic is good.
Is it always going to be negative 14?
What?
The atoms are always...
Well, if you multiply those two concentrations, it's
Okay, so it doesn't matter what it is.
10 to the negative of this side. Whatever you have in this column whatever you have in this column, okay, times what I had in this column, times will give you 10 to the negative 14. It goes back to the formula that I wrote a moment ago, which was the H concentration times the OH concentration equals 10 to the minus 14.
Okay, so from one of them was trouble, they added negative.
That's probably because you have a really strong, talk about that in a minute. And then the other side of that was that these two things, the pH and the OH, add up to 14. That goes back to those original formulas I had. All right. This is just some of the common, some things that you have learned or just know about. Status or acidic. Not real acidic, but they are acidic. 5.8 is an acid. So anything that is less than 7 is an acid. Anything greater than 7 is a base. And they use red and blue because most of the time the indicators that we use for acid are red. Indicators we use for bases are blue. Okay? That's why they use the colors that they use. Yeah, so that's just a 1 molar hydrochloric acid. I have 12 molar back there, which would be it would be a negative pH. We don't use pH to tell the, how acidic a really strong acid is or a really strong base. Bowel is, whenever you ever want to you get kind of sick to the stomach and you kind of burp up something really burns the back of your throat. That's bile. Bile comes from the gallbladder, and it's the digestive enzyme. Your gastric juice, that's your stomach acid. It's pretty strong acid compared. Your blood has to stay around neutral or fairly close to neutral. When you exercise and you get a lot of carbon dioxide in your blood would have a tendency to become more acidic. Because of the exercise, you also build up lactic acid that has to be taken away. And all those things should change your blood, the acidity of your blood to make it more acid, but instead we have buffers in the blood that help keep the blood steady where it should be. A buffer is something that resists change to pH. You think a tomato should be?
I just think it just seems like it would be
The best tomato you eat is the one that has an acidic content. The more acidic it is, a lot of times the better. Yeah. That's got malic acid, I think. Apples have got some acidity to them. Your urine, milk is a little acidic. The soil is acidic. A lot of times you have to add lime to your soil because it's too acidic. If you have pine trees, pine straw, make sure you put pine straw around your azaleas so that they will be more healthy to increase the acidity of the soil under the azalea. So you're constantly, if you're growing grass like on the golf course, construction would always take soil samples and send them off to get pH of soil. Just needs to be a certain pH to grow healthy grass. A lot of things you don't think are, but they're not, anything in here is not real acidic. It's pretty close to neutral. It's pretty weak as far now. Lye, that's what you put in your drains to clean your drains out. Red Devil lye. Sodium hydroxide. Very, very basic. And it's not good for you. You get down here and you've got lye and bleach and ammonia. You don't want to drink those things. Because it will kill you. It's not good for organic substances. But then you get down in here and you've got milk of magnesia, which you take to control your acid and digestion. Because it's a base. You have to neutralize the acid in the stomach. decrease this number is increasing. So that whenever you look at any two of them, when you say times, when you say times, that's not 10 to the minus 12 times 10 to the minus 2 is 10 to the minus 14. And this number plus this number gives us a total of 14. Anybody know what a log is? I know it's in your calculator. What does it mean? What does logarithm mean? Log. Log is the power of 10 that a number has to be raised. For example, the log of 100. The log of 100 equals 2. 10 has to be raised to the second power to give you 100. 10 times 10 is 100. The log of 1,000 is equal to 3. So 10 raised to the third power, 10 times 10 times 10 is 1,000. Now you get weird numbers, like what's the log of 2.5? Take your calculator out and say log of 2.5. 0.3. So 10 to the 0.3 power should be, so you do 10 caret top 0.3, it should give you 2.5. No problem. Okay? Learn that trig next year. Did it? Algebra 2? Okay. This talks about that one goes up, the other one goes down. I've already discussed that. Still ain't got the one I want. All right, here's a graphic of as the hydrogen ion decreases, the OH ion increases. That's what I want. All right? So, let's go back to our equations. I'm going to leave these equations up here, but I'm going to erase this other stuff that I have here. And I'm going to talk about your homework. All right? Ask questions about your homework. Let's start with the first page you have homework on, which was page what? 484. Okay, so let's look at page 484. Does anybody have questions? Do what? Let's look at number 4. It says determine the hydronium and hydrogen and the hydroxide ion concentration in the solution that is 1 times 10 to the 4th m. All right, so 1 times 10 to the minus 4 molarity, and it's CaOH2. That's the chemical. That's the concentration of the chemical. So this chemical is going to yield Ca plus, plus 2OH minus. Alright, so if this one is 1 times 10 to the minus 4 molar, then this one is also, because it's a 1-to-1 ratio, 1 times 10 to the minus 4 molar. But this one is a 1-to-2 ratio. So what's going to be the concentration of this? 2, no. What's 2 times 1 times 10 to the minus 4? Put it in your calculator if you don't know. It's 2 times 10 to the minus 4 molar. 2 times the number in the front, not times the exponent, because you're not multiplying exponents times exponents. If you were, then 2 would be times 10 to the 0 power, and if you added the exponents, you still get negative 4. Okay. So now I'm going to find the hydronium ion concentration. I have already done that, haven't I? What is the hydronium ion concentration? 2 times 10 to the minus 4 molar. Now I need this one. You with me? So the H plus times 2 times 10 to the minus 4 molar equals 10 to the minus 14. Now there's no need to put 1 times 10 to the minus 14. That's just extra stuff to have to put down. You can put it down if you don't feel right about it. Now solve. Divide both sides by 2 times 10 to the minus 4. Put it in your calculator. You know you need to use the exponent button, or you need to use second comma on a graphing calculator to get this answer. You do not put times 10 in your calculator. The exponent button or the second comma is like putting in times 10.
I got 5 plus 10 to -11.
That's what you should have got. So the H ion concentration is equal to 5 times 10 to the minus what? 11? 11.
2 times.
You put 2 exponent minus or second comma minus 4. 2 second comma, the little parentheses minus sign, not the minus sign that subtracts, and 4.
So you do that. E -4, E 14.
Yeah, you're gonna put in second comma on yours, minus 14 divided by 2 second comma minus 4. No. No, I don't think so. Not gonna be 10. I'll tell you why.
Calculated the 30 years of the small.
That, what now?
Like,
On this one, it will be,
Put in.
it's got exponent button. Did you put times 10? You put 10. Did I put 10? I said second comma minus 14. Not a 10. You don't ever put a 10 on this. You need to learn to use your calculator on this. All right. So, I'm going to erase over here so I have a place to write. All right. Do we understand that when we multiply exponents, we add, right? So it looks like that's going to be 10 to the negative 15, doesn't it? But it's not. And here's why it's not. All right? When I say 2 times 5, I get 10 times 10 to the minus 15. But that's not correct exponential notation, is it? So when I move my decimal place here, one place, that's in the positive direction. So I'm going to say plus 1. So now I get 1 times 10 to the minus 14. Because those two numbers in the front will multiply as closely as you can get to 10. Exactly 10. There are occasions when you round off, and if you were to check it, it would get 9.99, 999. You wouldn't get exactly 10. It would be very, very close. I'm just showing you that if you were to look at these, if you just look at this exponent, you look at that exponent, you look at that times that, it looks like 10 to the 15th, but negative 15. But this is why it is not 10 to the negative 15. So if you were to check yourself on a problem on a test, then you might say, oh, I got it wrong because that's 10 to the minus 15, just because I look at the two exponents and think that that's what it's going to be instead of thinking about that that's going to change. Okay. All right, let's erase again. So next page. Next page. Which
Yeah.
all right, 487. Any questions? We are going to try to find the pH of, let's do D. We want to know the pH of D. So we have 1.0 times 10 to the minus 2 KOH. Well, we have to look at our chemical. If we look at that chemical, KOH is going to yield K plus OH minus. And if this concentration is 1 times 10 to the minus 2, then this one is 1 times 10 to the minus 2 moles. I have to look at what is the ion that's going to be produced. So I look at my 4 equations here. I need to know pH. I need to know pH. I have several equations that have pH. I have 2 equations that have pH in them. And I don't have a concentration of OH in any of them, do I? Do I have any of them that is going to use that directly? Not by itself. So when I know I need to get pH, and I look at the 2 equations with pH in them, there's only 2 that have pH in them, right? And neither one of them have that OH concentration. I know 2 steps. I have to do 2 steps. I have to do 2 steps. Because I don't know the POH. I can't use the third one unless I know the POH. I can't use the first one unless I know the H ion concentration. So I have to do 2 steps. Regardless, I have to do 2 steps because no formula has the 2 things in it I need. So I know the OH concentration. Probably the easiest thing to do is to find the POH. And then subtract that from 14, give me the pH. You could also, I know that, I know the concentration of this, so I could use this formula to get the H concentration and then plug that in my pH formula. So there are several ways to use 2 of these equations and do 2 steps. You just have to decide which one you think you can do the easiest and the best. I'm going to show you what I think is probably the easiest one. All right, I need pH. I know that I have the OH concentration. So I'm going to use that formula and find the pOH. So pOH is equal to the negative log of 1 times 10 to the minus 2, and the unit is molar. Okay? Take out my trusty calculator, and that's 10 to the minus 2, so the negative log of that is 2. Put in the negative, the little parentheses negative, punch your log button, or some of you, you'll have to put in your number and then punch the log button. You have to figure out your calculator on this. But the answer is going to be 2. But am I looking for the pOH? Does that answer the question? No. The question is, what is the pH? Not what is the pOH? No, you didn't. You did with the negative sign in first. Oh, yeah. Okay, thank you. You did not put in your negative sign first. So pH is going to almost always be a positive. Now what now? How you got that? Okay. So now I take my pOH, and my pOH plus pH equals 14. So when I put in a 2 here, I subtract 2 from both sides. My pH is equal to 12. But it is a two-step operation. Two-step operation. Question. Pay attention to what chemical you're given. If you're given a base, then you're going to have OH concentration and pOH. If you're given an acid, you're going to have the H concentration and the pH available. Okay? So acids are going to come from the first and the third, and possibly even the fourth. The OH concentration, again, working with those three. Depends on which 2 of them you want to use. All right, next page of questions. All right, that was 487. 488. Now, the only difference in these is that they give you a number that's not 1 times 10 or whatever. They throw in some new numbers. So let's look at number 4. That's the hardest one. Determine the pH. All right? I'm going to erase this. Determine the pH. Well, I'm given SrOH2 yields Sr plus 2 plus 2OH minus. So if the concentration of the Sr is 2 times 10 to the minus 2, 2 times 10 to the minus 2 molar, then because this is a 1 to 2 ratio, this is going to be 4 times 10 to the minus 2 molar. And if you don't believe it, take that number and multiply it times 2 with your calculator, and that'll give you the 4. Right. I said, this molarity, I'm looking for OH minus, equals 2 times 10 to the minus 2 molar SR, that's moles per liter, SrOH2, and then I have to have a mole-mole ratio, which means 1 mole of this stuff, SrOH2, and 2 moles OH9. So I multiply those. Goes back to what we were talking about. Okay. So I have, in this case, I have the OH minus concentration, and I need pH. looking at what I have and looking at what I'm trying to get to, there is no single equation up here that has pH and pOH in the same equation. Okay? So I could take this concentration and plug it into this formula and find the H concentration. Or I can take the OH concentration and plug it into this formula and then subtract from 14. But I still have to do 2 steps because no one formula has both what I know and what I'm looking for in it. If the formula does not have what you know and what you're looking for in it, you can't do it 1 step. So, pOH is equal to the negative log of this OH concentration, which we said was 4 times 10 to the minus 2 molar. You take out your calculator and that gives you what? Pardon? 1.40 is the pOH. Remembering that the pOH plus the pH equals 14. That from 14 is going to give me 12.6 amps. Because you are, that 14 is exact, so keep your decimal. What now? Yes, you would subtract. Yes, it does say plus. I know the pOH plus the pH equals 14. That number is 1.40 plus pH equals 14. So minus 1.40 minus 1.40, that gives you. Remember, this number here is exact. So it doesn't limit significant figures. So truly your answer should be 12.60 because you are adding and subtracting. But on most pH problems, I'll be happy with 3 significant figures. Okay? Either the correct number or 3 significant figures is what I want. So either give me 3 significant figures or give me the correct number of significant figures based on the given in the problem.
But I think you go with the correct.
Because I know algebra, darling. If I were to put an X right here, there's an X right here. 5 plus X equals 14. Subtract the same from both sides. So algebra for me. But that's how I know subtract. It is algebra. Okay. If I'm given the pH and I'm asked for the OH concentration, again, you have to do 2 steps. Because no 2 of those things have the pH and the OH concentration. All right, any other questions from your homework? From your classwork? We should be able to do our classwork now and our homework. I worked the hardest problems of the practice problems for you.